Okay, we're live.
Okay.
Yep.
Hey guys, I'm Alejandro. I am a triager here at Immunefi. I've been with Immunefi for a little over 2 years now, and I'll be helping host today's call. I think we can go ahead and start with introductions with the rest of the field team.
Sure. My name is Cameron. I have been at Fuel for a little over 2 years now. My primary focus is the Sway language and building the standard library and language standards. Yeah, everything to do with Sway, really.
Sweet. Thanks, Cameron.
Yeah, and from my side, I already was here like last time, but yeah, I'm Luiz Stasio, working as engineer manager for the Edge, also working on Fuel for around like 2 years. Yeah, I started on the SDK side, and then after moved to more like the DApp sides, the things that we have that have interfaces and interact with contracts. And this is what I'm going to be talking also and showing a little bit.
Okay, great, awesome. So, yeah, I think we can probably go ahead and get into the technical part of this call, unless, Tim, did you want to give a brief overview of the Fuel Network Attackathon?
Yeah, sure. Why not? So,
Okay.
Yeah, guys, for those of you who's first time here, this is a third technical walkthrough with the Fuel team. We have conducted the other two, like first one was like 2 days ago, and the other one was on the last week. The purpose of these calls is to get through the main aspects of the Sway language, get through the main aspects of the Fuel Attackathon, to educate you guys on how to hunt. And for those of you who missed this, the Fuel Attackathon is the largest Attackathon, which is starting on dollars that you can grab. And yeah, Fuel has its own native language, which is called Sway. That's why we're all here to learn about it. And yeah, Cameron, Luis, Ale, passing to you here. Enjoy.
Yeah, all right.
Oh, Ale, sorry. Last minute comment. Guys, for those of you who joined outside of Immunefi, yes, so everyone who wants to listen, every security researcher here, you can send messages to the comment section. So in case you like don't see something or you have a question, just put it there. Please don't spam. But yeah, you can speak or you can turn off your video to to stay anonymous, which I think is fair. So in case you have any questions, just put them in the comment section. We will address them either immediately or like closer to the end of the call. Yep, that's it from me. Thank you.
Okay, perfect. Then I will get right into it, and feel free to interrupt me at any point. Can you all see my screen?
Yeah, I'll go ahead and field questions from the chat, Cameron.
Perfect. So the first thing we're going to start off with is I'm going to show you guys like the anatomy of a Sway contract. This here is you may have used this already. This is called Sway Playground. This is a great way to compile some contracts straight from the browser. So here we have a very basic what you would consider to be the equivalent of the ERC20 in the Ethereum world. So we have a single asset contract in all of our imports. Some things to note here is we have configurable and storage blocks. These are set on compile time, and storage is then set when the contract is deployed to the network. And we have some nice standards for everyone to use. So we have the SRC20 standard, which is our equivalent ERC20 standard. This is for specifically native assets on Fuel. And you can see here, these are our implementations. I don't necessarily want to bore you guys with just straight code, so I'll cover this pretty quickly. And you're free to check this out anytime on your own as well. There's a few different standards here. So we have the contracts, the asset standard, as well as our ownership standard, as well as our minting and burning standard. So you can implement multiple standards per contract. One thing to note is the difference from, say, something like Solidity is we don't have a functionality to extend. So you would be implementing for your contract these predefined ABIs, which are part of the standard. There's also some attributes that are needed for your contract calls. So we have storage reads and writes attributes. Without these, your functions will not read or write storage. So you can really fine tune and make sure that only the functions that you want to be touching storage are touching storage and modifying the things you want. We also have a payable attribute. This ensures that only certain functions will accept assets for a contract. This is a single asset contract. There's also the multi-asset contract. This is effectively the NFT on Fuel. One thing to note is that as we have native assets, any asset on Fuel is native to the network. So the SRC20 standard is used for both a fungible asset and a non-fungible asset. The difference being it's a mint limit of 1. So there's only one per the standard. There's only one, and you would implement the same exact SRC20 for both NFTs and fungible tokens, and any interactions you have between the two are completely identical. There are some nice applications here in our Sway apps. I highly recommend checking these out. These are great example applications and show you the basics of how to create a variety of different apps on Fuel. And something to note for the security side is the native assets and as well as implementing certain standards. As I mentioned, we have a Sway standards documentation here. There's quite a few different standards and something to make sure that you're using properly so that everything interacts correctly. There's a few different things here, such as upgradable proxies, the native assets, and ownership, which are really important, as well as anything that's touching assets like minting and burning. Then I will go on to how a user can interact with a contract from the code level. So I've written a very basic contract here.
Alejandro wants to talk here.
Oh, yeah. I just had a quick question. So that standard library, security researchers can basically think of this kind of like Open Zeppelin's standard libraries for Solidity.
Yes. So we have our Sway libraries here, which actually implement a lot of the Sway standards. And the standards here define specifically the specification of how to implement a native asset on Fuel.
Okay.
Yeah,
great.
I think different from Open Zeppelin, the only difference, the biggest difference, not the only, is that we have the interfaces defined here as like the standards do also, but we don't have the full implementation of the contract, but we provide the utilities that you can use to build the interface. Because in Sway, you don't have the ability of extending a contract, but you have the ability to implement the methods of the interface.
I see. So the implementation from different projects may be slightly different.
Yeah, like in this way, if you see like it implements the interface and also use the same utility methods that we have on the libraries, and we have these for most of the standards.
Okay, got it. Thanks for the explanation.
Okay, perfect. So I have this basic contract here. This is going to be an example of a cross-contract call. Here we have, on field, we have a base asset, and it has a base asset contract. This here is our base asset contract. It's very simple. It's just a simple SRC20 implementation. And the asset is ether, returns the name, symbol, all the good stuff there. So this test contract here will define the ABI for the SRC20, and I pass in the contract ID of the base asset, and I can query any of the information from the base asset contract that's deployed on the testnet. And for interacting with this, there we have some, so this is our Rust SDK harness. And it's already been deployed, and I've already written some tests to make sure that we can get things like the total assets, and we can interact with the contract. So now I will show deploying. Actually, I've already, since this is a live demonstration, and oftentimes things go wrong with live demonstrations, I've actually already deployed this contract on the testnet. This is the contract here, and you can view the bytecode. There is a bytecode root solver, so you can take this and compute against the bytecode root, and you should be able to get this. Right now, the asset doesn't own any contracts. This is our Fuel Explorer, by the way, and this is our showing our contract. I have then interacted with this contract here. And here you can see a cross-contract call. So we have one call to the main contract and to the base asset contract. And then I think I called here the total assets function. And because the base assets, there's only one, you can see here the value returned is 1. So this just gives you a little bit of introspection between contracts and like how you would check something on Fuel Explorer, and all the good stuff there. Then I am also going to briefly go over deploying the contract to the test network. So I've actually already done it here from the.
Just a question, Cameron, that it's in the chat. Can you show where the function selector is on the transaction?
Let's see.
Yeah, it's the method there inside on the item of the operation.
Yes. So right now you can see this is just the there's no nice and pretty I think version of this.
Does the Explorer allow for contract verification?
No, not right now.
Okay.
That is something that I think we have planned in the near future. Is that it?
But yeah, I think that's pretty much it. The method there, like, and is the hash of the name of the method, the function itself. Yeah.
Okay, perfect. Then there's two ways to sort of deploy your contract. One is through the command line, and one is through the Rust SDK. In the Rust SDK, I've already done all of that here. It's just simply calling the deploy function on my wallet, making sure that it's been funded, and it just deploys to the testnet. I'm also going to show you how to set up your like a local node. The same process can be done on the Rust SDK for a local node, and I've already pre-set up here my fuel core. So this is just downloading fuel up. So you can download fuel up you can find it on our GitHub. You should be able to find it in our docs, and it'll give you access to this. You will need to get a chain configuration if you want to run the testnet locally. And this is the recommended one. You can find actually like all of this. We have a nice a guide here of running a local node on your computer. And I will just be running the very first thing up here, setting the snapshot to our chain configuration from this repository. So when I run this here, I'm now running a node locally, and I can actually deploy this exact contract to my node. So I'm going to use fork deploy. I will use a pre-funded default signer. When you're using a local node, if you use your own wallet, so fork will generate wallets for you. But if you use your own wallets, just know that it won't be funded unless you're doing it through the Rust SDK. So default signer works, and then you're setting just locally. So if I go ahead and deploy, give me 1 second. Waiting. There we go. So I can see my contract ID has been deployed, and then you can go ahead and interact with it. To do that, you are going to need either through the Rust SDK, or you can do it also through the Fuel wallet. So if we unlock here, by default, you will be on the Fuel Sepolia testnet. And you can add your local network by adding this URL here, this IP address, by hitting add a new network, and you get your local network. My wallet here is not funded because I just spun it up. But you can then send fuel funds to this wallet and interact from there. And I think that's like a very basic run through of setting up a wallet, setting up a node, deploying a contract, and highly recommend checking out our quick start guides of deploying some nice, easy counter contract, just a few commands. And what I recommend focusing on the most as a security perspective is because Fuel, as I mentioned earlier, the native assets, the biggest difference of what people are used to from there's no longer any token approvals. You don't have it once an asset's in your address. There's no spending conditions, and you don't have approve from. You don't have approve all, and as well as on our compiler side. There's large differences in the compilers. The philosophy is the compiler is your friend, and we have very nice things like reentrancy built into our compiler, so it'll warn you. And anytime you're touching storage and making contract calls afterwards, so if I were to add some storage here and make a call to storage afterwards, it'll notify me. And yes, I think that's it.
Yeah, I had a quick question, Cameron.
Yes.
I know you mentioned that you can interact with the network through the UI or with the SDK. Is there an easy command with fork where you can interact through the terminal and read values?
So currently through fork, there is no no exact command for interacting with the contract. You can get the contract ID, but we don't have something so that you can create a new transaction through fork.
Okay, gotcha. And you can't read state either through the command
Through
line
fork,
tool?
no.
Okay, gotcha.
Okay.
Okay.
Any other questions related to what Cameron showed?
Yeah, if any of you who have joined have any questions, please write them in the chat.
Yeah.
Okay, here we go. We have one question. So what would be the best way to send a transaction to a test node? I think Luis might be answering that soon here.
Yeah, I think Cameron, you can answer that also, no problem. I think it's
Sure.
related to what you have there.
So you can interact either directly through a wallet. So say here I'm force transferring to contract, and I specify the base contract. The best way to do it through is probably through the Rust SDK. You would, for the front end, Luis will cover that. But at least with the Rust SDK, just make sure you set up your wallets and then transferring it to that contract, or add interactions through contracts with other contracts or predicates. I didn't cover predicates, but those might be something you can look at as well.
Yeah, I'm going to show a little bit predicates here.
Okay, I will then stop sharing my
Okay.
screen.
Yeah, I think just to finish that, like the best way to send the transaction, in my view, it's using the tests, like using the test to send, because you can send to a local and you can send to the test net also, and it's repeatable. Like you can do in an easy way with the UIs, but yeah, would not be the best way, I would say, to be interacting. Okay, let me share my screen here, and this one will be the. Okay, what I'm going to show, it's more related to how the dApps connect, and this means like how you can have like a wallet interacting with your application. Let me get here an example that is working already. We have the connectors, that is the way that wallets can be developed to interact with Fuel network on the dApp side. And normally the dApps, right now we have React, but it's also possible to not use it with React this code, okay? But the idea is that we have the connector manager that allows you to have many connectors. And the connectors can be as simple as a Fuel wallet connector, like this one that I can display here, that is just using like plain wallet extension that works directly with the Fuel network. But we can also have connectors that use predicates. And this is what like Cameron was talking about, that I want to show a little bit. It's not something that you like you may like look to these connectors and the codes just to see how they work, and because like this is like the way that Vue has account abstraction. We probably are going to be covering this more when we go like for the language itself. But the main idea is that you can use any wallet that you already have. Like in this case, I'm using MetaMask to interact with the Vue network. And I'm going to show the functionality first, and then I'm going to go there and show the code after. I'm not a robot. Okay. And then here, like right now, I have like my MetaMask connected, and I can interact with the Vue network by signing messages. If you see, like I was able to interact with a contract on the Vue network, just signing a message. And this allows like for any wallet to be integrated with Vue. And the way that we do this, it's by having the predicates, that is the account abstraction part. And here inside of this folder here, we can see the predicate code itself. I'm going to increase the letter a little bit because I suspect it can be like really small. And the idea of predicates is that they implement the logic to verify the signatures. In this case, we are assigning this the hash of the transaction. And once we like you are doing a transaction, you provide the bytecode of this predicate inside of your transaction with the signature, and it verifies on chain that the transaction, the signature is valid. This means like you are really the owner of that code. You are really owner of that address by verifying the signature of that message over the transaction ID. And if this is true, then you are able to spend that money, like that UTXOs, or no. And the main idea for the predicates is that we have one for like wallet connector. We can have another one like for another application that we have. There's a multisig that is called Baku. We have like for whatever, like we are building for Solana also. And this means like with predicates, you can do any verification in signatures. We have like many supported signature verification schemas already. But yeah, I think this will be like something nice to take a look, predicates. But I'm going to be covering more on how to integrate like with a DApp. Here I have like a counter contract that is Sway. And when we are working with TypeScript, we can generate from the Sway contract and the ABIs. We can generate the types almost like what you have with TypeChain on EVM chains. But we have like a simpler way also, like a tooling that you just create like this fuse config ts file here on the hood of the hood of the package for the project, and you just specify the configuration that you can point to the folders where you have the contracts. You can specify the outputs, like where I want to put the types that are going to be generated, and you have some more options here. And you can also consult the documentation for the TS SDK. And then once you have that, let me increase the letter here. You can run npm fuse build on your project, and what it's going to do, it's build the entire contract and also building the types for you. And with that, you are going to be able to see the types generated for you to interact with the contract. And this is normally like how dApps do, like they normally use TypeScript. And this is why we have this type of tooling. And then if we go here, and I'm going to go through the part that we consume the contract. Counter here. And then with this there, like with the type generated, you can just simply like import the counter factory that is just a class from here. And you can connect to the contract deployed on chain that it's here, the ID already for me. And you can pass the wallet. And in this case, the wallet comes from like the connector. When I use the connector, I'm able to also select the wallet. And once I'm connected to this, then I can do like, I can execute the functions pretty much like what Cameron showed on the Rust side. I can do like contract.functions and call the methods of the contracts and pass the transaction params. And I can do like calls, I can do like dry runs, I can do all the functions that the node provide here. And with that, you're able to interact with contracts. On the DApp side, just to show like the connectors part, I think it's here on the wallet. I think it's better for me to show the documentation here on this one, wallet connectors. Then it's like almost like you have the connectors list, everything that you want to connect, and then you are able to just specify, like select a connector that you want to use, and then you are able to connect to different wallets. I think that is pretty much it of like dApps connecting with the wallet. Any questions here that I can expand? No? Okay.
Yeah, no questions in the chat just yet. Those of you who are in the audience, please, if you have any questions, throw them in the messages so we can get our fuel experts here answering those for you. I did have a question of my own, Luis. I just wanted to ask, what would be the best way for a security researcher to then test a dApp which was deployed? Should they replicate it locally? You know, what kind of tools do they have at their disposal too?
Yeah, right now I think the best way is to like if you want to replicate like all the current state of the network, you can run like a node locally to sync with the testnet, and we have documentations to do that. We don't have a way to fastly fork the network. This means like you need to sync a node first to be able to do that. Other way would be, oh, let me get the docs here. I'm talking, and then when I'm talking, I'm not thinking. Here, running a node. And you can also like interact directly with the testnet, and you probably need to have the ABIs of the contracts to be able to interact. And for that, you can go to like our ecosystem page. To see what are the contracts that are deployed. Like you can go here and see like the GitHub that they have, and see the contracts like that they also are developing. In this way, you can have the ABIs also to interact with the contracts and also see all the tests. I think this will be the easiest way right now, as we don't have like an explorer with verified contracts. If it makes sense and it answers your question.
Yeah, that answers my question. Thank you.
Oh, I was not showing my screen.
Oh yeah, your screen is not being shared right now.
Okay, let me just go again here, like pretty quickly. No, yeah, I was showing here, like, yeah, the things that you can go here on the docs, and you can go to the guides, and you can go here running a node, and this would be like to sync the node locally and be able to like simulate the same data if you don't want to be trying things directly on the live testnet. And if you want to test like specific contracts, and you will need the ABIs, and then for that you can go here on the Explorer app, that is and go to the ecosystem page, and here you have all the projects that are developing on the network, and then you can see the GitHub page, like the GitHub from the projects. It makes sense?
Yep, that makes sense. Just posted those links in the chat. We do have another question here from Jessica Poe. Those Sway contracts, would they be part of the first or second part of the Attackathon? So I think this White Hat's referring to the separate pools for the dApps that are built on Fuel, and then for Fuel itself. What aspects of Sway will be for the first part of the Attackathon, and maybe what aspects will be for the dApps part of the Attackathon?
Yeah.
For example, like the Sway compiler, will the Sway compiler be in scope, or the standard libraries in scope for the first part?
Yeah, I will not know like exactly how to answer that. I will defer for someone else, and then like we can answer after, just to make sure we answer correctly.
Okay, yeah, no problem. Yeah,
Yeah.
that should be in the scope section of the bug bounty or the Attackathon page, sorry. So you will be able to get an answer for that soon. We have a question from Savior. Is there public RPC available for Fuel Network, or do you have to run your own node to have an RPC?
Yeah, as Cameron said there, we have the GraphQL endpoint that you can use directly to query. You don't need to run to be able to query the testnet. And he sent directly the link of the RPC. But if you want to see the playground, as ours is like GraphQL, you can enter directly on the playground here and do directly queries here. And you can also query history data. You can't do like a lot of like sorting and things like that. Probably you don't need that, but you can almost like do anything that is for like investigating and see the transactions. You can use the playground also. And also on the Explorer side here, you also are able to, like, example, get a transaction from here and go to Advanced tab, and it's going to show almost the same data that you're going to see on the playground, and you don't need to be doing the queries. Like here, it shows like all the data also for the transaction. I was, again, not showing my screen. Nice. Please, guys, don't let me do this. Here on the, you can go to the playground here, and you can like do the queries and see all the data, and you can do like almost all the data here, all the queries, history also. And on the Explorer side, you can go here on the Explorer, and you can see the simple version that is like more visual, but you can also go to Advanced and have the same thing that you would have here on the playground, but it's already done. You don't need to create the queries, and then you can see all the data here.
All right, yeah. Thanks for showing that. We have another question from Imudiduna. Sorry, can't pronounce that. But within Fuel VM, I can see that transaction script type is an array of integers, vec u8. So how does a signed transaction get converted? I'm not sure if you can answer that. Was that enough information to answer that question?
Yeah, I'm reading that just to make sure I understand what he means. Yeah, I didn't understand exactly what he's asking.
Okay, maybe you can expand on that question a little bit. But while we're waiting for that, I did have one last question here from my side. What are some of the most important security concerns when developing and writing dApps using the Sway language? Yeah, so do you have any like common pitfalls, resources that the security researchers can review?
Cameron, I'll let this
Yes.
for you.
So the main thing is just getting used to the difference between something like an ERC20 and a native asset. And since we are like a UTXO model rather than a cow-based model, any of the differences between that and anything you can query on chain versus that you may not be able to otherwise, as well as predicates and how they are used to manage assets and the ability to introspect within the UTXO and unlock certain functionality.
Okay. We have another question from Xavier. Can we interact with the contract on the Fuel Explorer like with the Etherscan UI?
No, not yet. Not yet. You really need like to create like a test application to be able to interact with the contract.
All right. And then the second part of the question was, can we verify contracts? But yeah, we did go over that. And I think the answer was no.
Yeah, exactly.
Not yet. Not yet.
Not yet. Yeah, not yet. It's on the roadmap.
Yes, no, you cannot verify these from the Explorer, but there is a bytecode root solver library, so you can compute the bytecode root and verify on chain that a contract's bytecode is what you expect. But there's it's not like hooked up into to the front end for the Explorer.
Okay.
Yeah. I see the question here. Yeah. The question is, would it be possible to get a how-to on how to set up a bridge Ethereum fuel? We would like to test that. Yeah, like you can do like for sure through the UI, but I think this is not what you're asking here. If you want to like run an infrastructure that is going to simulate everything, you can go to our repo and you could like run using our Docker Compose that we have inside of the repo. Let me share my screen here. This time I'm not going to forget. And is here inside of the repo, you can go to the Docker and you have a Docker Compose file. And this one, it's going to spin up like a layer 1, the fuel network, and also all the other components required to do the bridging system. And you're going to be able to test everything locally and simulate. And then like, if you want to like test with the real Sepolia, then yeah, you also can have like the contracts here. You can see the IDs of the contracts instead of the deployments folder. If you go to the testnet, that is what we are covering. You can see all the contracts that we have with the IDs to make sure you can also test these after on Sepolia. It answers your question?
Yep, you got a thumbs up. So
I can cover this on scripts. Fuel has three types you could say. We have scripts, we have predicates, and we have contracts. Scripts are any form of script just written in Sway code that can be run, and you can call contracts, and those contracts can then access state. And predicates, on the other hand, are sort of like scripts, but they cannot access state. They can only introspect on the UTXO itself, and they always evaluate to a Boolean. And the way you can think of these is that they are sort of like the code itself becomes a private key, and when the code executes to true, the private key signs, and any assets owned by the address or the bytecode root of that predicate, then unlock and can be transferred. And then contracts, pretty self-explanatory. The main difference between scripts and predicates being a script can interact with contracts while a predicate cannot, and a predicate has an address, much like an EOA, while a script does not. Does that help? Okay. Between scripts and contracts. Contract it has storage and is deployed to the network. And it's like contract, just like in other ecosystems. Whereas a script calls contracts and is not deployed on chain.
I think I would state this as like the contracts are the piece of software that contains like methods and things like that, and it's deployed on chain. It has state. It's stateful. This means like you can change the state that it has, and the scripts are like just like a piece of code that it runs during the transaction. It can have the calls to contracts that have storage, but it doesn't have storage by itself. And this is also true for the predicates. That is one of the types of script, but it can't call contracts. It can only introspect on the transaction itself. It has answered the question for the difference between script, contract, and predicate. I see the other question here, the last one. I'm just waiting to see if we answered the other one that we're trying to answer. Not yet? Didn't reach? Okay.
Yeah, I think it would be helpful to link some documentation as well here.
Yeah, I'm looking into that right now.
Yeah. I know that, yeah, there's a lot of really great documentation that you guys have that the security researchers can refer to.
Okay.
And yeah, we can probably move on to the next questions here.
Yeah, the other one, I'm trying to read here to just get what it means.
So why would I call a contract with a script and not an EOA? It's basically for any extra functionality. So like an EOA, you can just call a contract, whereas with a script, you can gather any information. So you can gather anything for the UTXO that you might need, I don't know if that helps at all. The best resource that I can give you is checking the docs.fuel.network documentation, and that should explain it a little further. Any interactions, so like the SDK, any interactions is already done with a script behind the scenes. So to interact with contracts, you're going to have to use a script regardless. It's just you have the ability to write any scripts yourself.
Yeah, I'm not getting the question itself, like what do you mean, but I can try here. Like, you don't sign through like when you sign through the hash of the script. All the transactions, like all the transactions that are going to call a contract or do a transfer, they are transactions of the type script. This means like every interaction that you do with the the chain has a script, and the script is part of the hash of the transaction. And what you sign is just the hash of the transaction. You don't sign specifically the payload of the script. Like this is included on the hash, but it's not just this. I don't know if this is what you're asking, but it looks to be more on this direction, but I'm not 100% sure yet.
We have one more question on the script. So the short explanation would be that with a script, I can make my EOA transaction conditional based on some blockchain state. Is that correct?
Yeah, exactly. In the script, you could verify like some state on the blockchain and like reject the transaction if you want. It's a script, and it means that you can do like any arbitrary logic that you want.
Okay. Any more questions? Yep. Luis, back to you.
Yeah, there's one question here. I saw also in a transaction something like asset ID. Could you explain what that is?
Yes. So an asset ID is the ID of any native asset on Fuel. The way that this is calculated is the contract that mints this native asset plus the sub ID identified for that asset. The hash of that produces the asset ID. So that means any contract can mint any up to U256 assets, and they will all have a unique ID. And so this is sort of, you can think of like ERC 1155, I think. So like a multi-asset standard. And that asset ID is just what provides the unique identifier for each asset on the Fuel network. And so every single asset will have its own asset ID.
Yeah, you go ahead, Cameron.
There was another question. Isn't ETH the native asset on the Fuel blockchain? Yes, it is the base asset, but every single asset is native, meaning every single asset is treated like there's no approvals. They're all native to it. The equivalent would be as if every ERC20 was as simple as transferring as Ether. I don't know if that clears that up. So SRC20s on Fuel all function like ETH. Yes. They are all native, so there's no approvals, no spending conditions when they're owned, and all native to the actual network, rather than a smart contract that manages what the value is for for a certain address.
Yeah, you don't like you currently you can't use like any ERC20 to pay for the transaction. For this, you use the base asset. This is how we calculate the gas. Like the node can specify what is the base asset, and it can be anyone, but like for now it's Ether, and you only pay on Ether. But the other assets you can transfer without the need for interacting with a contract.
And we have another question on that as far as paying for transactions. What prevents me from creating a dummy SRC20 and using it to pay for transactions?
Yeah, as I mentioned, like when you run like the network, we specify what is the base asset for the network, and then it needs to be the base asset. Then it means like you can do that, but you can't pay for a transaction.
Gotcha. Okay, guys, was there any other questions that we may have missed, or any other questions that you all have? We're getting a lot of good questions already. We got one more maybe coming in.
This guy is a machine or this person.
Yeah, we have one question about the contract UTXOs, but I think that might be a topic for another talk, or we've already have a talk recorded on that. Is that right?
Yeah, I think we already have something recorded for that, but like a quick explanation is just like the difference that one tracks the asset, this is the UTXOs, and the other one tracks like the state hood. And this is what you pass. You pass like the state that hood that you are going to be changing, and then you receive output that is the hood state after the update. That will be the simple answer, but I think you can go to the documentation, also to the previous calls to get a better explanation, like more deep.
Okay, here's that question. So regarding the client, is it not referred to as the sequencer, yet fuel is a roll-up technically? Could we have multiple clients that update the state of the blockchain to L1? So the question here,
right now, no, and in the future also no, because of the shared sequencer that is going to take care of this. But technically, exactly how the architecture works, then I would defer for another person to answer you. And probably on the next call, we can have someone to answer this better.
all right, I think we can do a last call for questions here. They're coming in a little bit slower now. And we'll just wait 1 minute.
Guys, as a reminder, we're gonna have 3 more technical walkthrough calls with Fuel team, so we might want to give them some rest from your questions. just kidding. Just kidding. Okay, Skellyman.
Yeah, so, okay, the question here, SRC20s and ETH on Fuel don't really function the same, but the difference is abstracted away in the Sway code. So I think he's, asking for the comparison between the SRC20s and then the native asset.
So both are native assets. ETH is just the base asset. So ETH is what you're paying your gas fees in. SRC20s are just native assets that are moving around as UTXOs and do not need smart contracts to be interacted with.
but the base asset also has like a construct deployed on the chain.
Under the hood, they're both native assets, so they're both any functionality one has, the other one has. There's no like special functionality like you need for ERC20s, and like there's no reason for like a wrapped ether. But all gas is paid with the base assets ETH, and everything else just moves without contract calls, and this means we can do some really nice things with our predicates as well as parallelization in the future. Yes, ETH is just the designated as the only native asset that pays transactions. Yes, because it needs to pay to the L1. So if validators disagree on the current state of fuel posted on Ethereum, how does the protocol handle it? Are validators trusted? Right now, it is a proof of authority. I would defer to some of my colleagues to really give you better insight on this. But as of right now, we have a single sequencer, and then in the future, any disputes will be handled when there's the shared sequencer involved.
All right. I think with that last question, we could probably start wrapping it up here.
Run, everyone, run. Yep.
Yeah, thank you very much, Cameron and Luis, for giving your time here. Your technical expertise was very much appreciated in this call. Tim, do you have any final notes here?
My final note is that to Jessica Bo, congrats, man. Yeah, no reward, but definitely the MVP. Hold on, one more coming in. All right, guys. Thank you, everyone. Thank you for this technical walkthrough call. Fire away, man. Oh, okay. You got me there. You got me. Okay. All right. Thank you, everyone. Guys, the recording will be uploaded to YouTube by the end of today and will be shared in our Discord. So stay tuned. And the next technical walkthrough call will happen in 2 days on June 14th. So stay tuned for the updates. Yeah, thank you, everyone.
Thank you,
See ya.
everyone. Thank you for all the questions.
Bye-bye.
Thank you. Bye-bye.